Hey everybody, it's Brian here with another SPSS video. Today we're going to talk about correlation and regression analysis in SPSS. So here we have our Halloween data set opened. With correlation, we'll start with that. We're looking for the strength and direction of the linear relationship between two variables. So for larger values on one variable, are we expecting larger values on another variable, or maybe smaller values on another? So we're going to look at these last three variables in our data file: houses and candy and chocolate rating. So houses is the number of houses we visited on Halloween. This is the candy, the amount of candy we got, each person got in ounces. And then the chocolate rating. Everybody rated how much they like chocolate on a 1 to 7 scale. So we're going to see if there's any relationships between those three variables. And SPSS has this cool way to look at more than one pair simultaneously with what they call an intercorrelation matrix. So to do that, we go here to the Analyze menu, choose Correlate and Bivariate. And then we can simply drag over all the variables we're interested in. So I can shift-click to select a whole range of variables there and pull those over and leave things at their default here and choose OK. So here's our intercorrelation matrix. And at first glance, this can be a little bit confusing to read. So let's take a minute to walk through this format. So each row here is each of our three variables, and then each column is also each of our three variables. And so we can see the correlation between number of houses visited and number of houses visited is 1. There's obviously a perfect relationship between a variable and itself. And we see that going down the diagonal of this table because that diagonal represents comparing each variable to itself. Not very interesting, but something important to notice. But then when we go number of houses visited to candy received, now we see here the first row here, 0.736, is our R value, our correlation coefficient, followed by our P value. So this is saying, yes, this is a significant correlation, and it's based on 50 pairs. If there were missing data in here, it would only show the number of pairs that had complete data for both variables. And so we see, yes, there is a strong positive correlation between the number of houses visited and the amount of candy people got, which kind of makes sense. Moving on to the next one, we see the number of houses visited has no real relationship with people's chocolate rating, which also makes sense. We have a negative 0.197 correlation coefficient, but this p-value says that it is not significant. So then the last correlation that we can look at here is a relationship, moving down to this one, candy received to the chocolate rating, which again has really no relationship. 0.022 is the correlation coefficient and a really high p-value. So we're not seeing any significant relationships here. So these three values here represent all of the analyses of these three different pairs. So notice the bottom part of this table is actually just sort of the parallel across that diagonal. Here's that same correlation, but we're now comparing candy to houses instead of houses to candy, but it's the same thing. In a correlation, it doesn't matter which variables are X and which is our Y, we're still gonna get the same correlation coefficient. And the same thing here, this negative 0.197 is already shown. So there's a lot of duplicate data here. It's important to pay attention to which relationships you're looking at in this intercorrelation matrix. The last thing I want to point out is that relationships that are significant, they put a little flag for us. This double asterisk is saying that it's correlated at the 0.01 level. So that's sort of an easy way to eyeball which of the relationships in this intercorrelation matrix have reached our threshold of significance. So that's correlation. Let's look at a similar analysis, a related analysis, which is regression. So let's pick this one that is significant, the houses and candy variables. So to do a regression analysis, we simply go to Analyze Regression and choose Linear. There's a lot of more complicated regressions in SPSS, but we'll stick with the basic one. Here it does matter which is our X and which is our Y. So I'm going to choose houses as our X and see if we can use our regression to predict the amount of candy received. So we pull that over as our independent variable and choose OK. And so here we go with our regression analysis. We have a lot more data here. Our first table is showing us which is our dependent and which is our independent. Then the model summary has our R² value, the proportion of the total variability in our candy received that is predicted by the number of houses you've been to. Notice this R is our correlation coefficient that we saw, but do be cautious. If we had had a negative relationship, this would still be a positive value. So even though in a simple linear regression, it's pulling over a correlation, it drops the sign. So be cautious of that. Here's our ANOVA table telling us whether our regression analysis is significant. So here's our degrees of freedom, the F obtained for that analysis, and then this p-value is telling us that yes, this is a significant regression analysis. And then down here we have the ability in this sort of arcane table of coefficients to figure out the slope of the line. And so it's here under this B column is the two components of our equation for the line. And so the slope is here under the candy received, this 0.402. So this is saying that for each additional house I visit, I predict that we get about 0.4 ounces additional candy. And then the y-intercept is above it with this row label constant, 9.77, which is a little bit weird in this context. It's saying that if I visited 0 houses, I would still expect to receive 9.77 ounces of candy. So again, the y-intercept is sometimes highly hypothetical, as it seems to be in this case. But this is how we find those two values for the equation of the line from our SPSS output. All right, so that's correlation and regression in SPSS. So thanks for tuning in, and I'll see you in a future video.